All right. Hello, everybody. We'll give it a couple of seconds for everybody to trickle in here. But welcome everybody to today's webinar, Coding and Building Performance Simulation, presented by the IBPSA-USA Education Committee. Some housekeeping items. Today's session will be recorded and available through the IBPSA-USA YouTube channel. If you have any issues hearing the presentation, please try calling in by phone. Instead of using the computer audio, this is a Zoom webinar, so you can participate by posting questions and comments in the Q&A tab at the bottom of your screen. Questions will be viewable by all attendees, and there is an option to submit anonymously if you prefer. We will have a Q&A section towards the end of the webinar to address your questions, but feel free to input them as we go along. You can also upvote or comment on the question that resonates with you. We welcome questions, thoughts, and ideas as we continue to work towards IBPSA-USA's mission of fostering better buildings through simulation. I would like to introduce today's speakers in order. First, we have Justin Schultz. Justin, working alongside architects and engineers, Justin uses computational analysis to answer our most pressing sustainable design questions. As the leader of Page's building performance analysis team, he collaborates with clients and design teams to define sustainability goals, develop strategies, and evaluate pathways to success. Justin provides performance-based recommendations that guide buildings to a more sustainable future. Our second speaker is Jake Chevrier. Jake is a computational designer and senior performance analyst with over 10 years of experience working in Smith Group's San Francisco office. He draws from his experience as both an engineer and architectural designer to find sustainable synergies and drive decarbonization within the built environment. Jake is dedicated to a cleaner, greener, and more sustainable future and enjoys working on technical, data-rich projects that require creative problem solving. And Greg Collins. Greg is the founder of Zero NB, an energy modeling consulting firm, and the BEM Toolbox, a platform providing free tools to energy modelers. He has 16 years of industry experience and volunteers as a member of the IBPSA-USA Building Data Exchange Reporting Working Group, chair of the IBPSA-USA California BEM Practitioner Advocacy Committee, and a non-voting member of the ASHRAE 90.1 ECB Subcommittee. His current goal is to deliver better BEM reporting to the industry. And today's moderator, Kate Bren. Kate is passionate about visual communication of building performance as a performance consultant at Cyclone Energy Group. She analyzes energy usage efficiency and renewable energy, explores workflow improvements, and crafts compelling graphics to complement the firm's work. Kate is an engineer in training with 3 years of experience and two-time Project Stasio winner based out of Austin, Texas. Please join me in giving them a warm welcome to our speakers. So I will turn the time over to you, Justin.
Awesome. All right. Kicking things off as the first one to go. Today we'll be talking about coding and building performance simulation. I am Justin Schultz. I've been at Page for 6 years. I'm the building performance lead. I have a BMP, BMP. I have a PhD in architectural sciences, as well as a BS in energy engineering. And I've been scripting for about 10 years now. So this is a bit of my journey and some recommendations on how to get started. So what did I learn in the first place? I had the opportunity to join my PhD. It's really good to take time when you find it and say, what can I learn and advance my own skill set? I really want to look in terms of automation of repetitive tasks. I hate doing things over and over again. It's one of my biggest pet peeves. So if I could automate something by scripting it, I absolutely want to do so. I also was looking at in terms of data analysis and visualization. We create a lot of data with our energy simulations. Are there better ways to analyze and script it? And in particular, I hate Excel with a passion. So anything I can do to script it makes it a lot more fun. It's also solving engineering problems. So, writing your heat transfer, thermodynamic problems in Python and solving them was a really great exercise in my PhD, as well as how we've been using it thereafter as well. And it really helped in developing programmatic thinking. This is something that is beneficial not just to Python programming, but also to just how we address problems in a whole. Even when you're working in Grasshopper, you're setting up a building performance simulation, it really benefits to think, what are the pieces that I can break this task down into that are repeatable and can be reused across multiple domains? And lastly, it's really stinking fun. Programming is really, really fun. And I really recommend that you get over that initial hurdle of it being uncomfortable to finding out that it's just way more fun to create a visual in Python than it is in than it is in Excel. So what are my recommended resources for learning? In particular, I have two. This edX by MIT, the Introduction to Computer Science and Programming Using Python, is actually the program I used to learn 10 years ago. It's so successful, they've been doing it every single semester all 10 years. The next one starting in just 7 days, which is really, really great. So go out there, sign up for the class, give it a try. It's 9 weeks long. They say it takes about 15 hours per week. I think if you're a building performance analyst, you're going to feel right at home scripting in Python, and it will probably take you maybe 5 or so, maybe 10 hours a week as you get started. But I think it's really fun and you'll have a great time. If you want to go your own pace, Real Python's probably one of the best resources for learning Python, in my opinion. They have a Python basics book that's really super simple, pretty concise, and has some really, really great use cases in there that will get you started right away. So I'd recommend that. Another great learning resource is ChatGPT. We didn't have ChatGPT when all three of us learned, but I can guarantee that we're still using it today to help us with our programming. So it really is a beneficial tool. I asked ChatGPT here on the left, this is an EPW file. I want to use a pandas data frame and plot the dry bulb temperature. When you do that, it not only plots it for you, but also gives you the Python code that it would use to do that. So with plugging in that prompt, I got the code there on the right, which is able to create the graphic on the left here. What's great about it is even when you get errors, because it might not get it right the first time, you plug those errors back into the same chat and it's going to say, oh, I see what I did wrong. Let me update the code to fix that. So the only thing that you have to do if you were to update this is correct your file path to be something local to your own machine or referenceable. Beyond Python as itself, Python becomes very powerful when you look at it in terms of packages. And Python is by itself quite good, but packages are really where you start unlocking its potential. And there's several packages I just wanted to highlight as it really highlights and will make the use of Python in your own career more successful. The first, number one, and my most used package by far is Pandas. Pandas is a method for basically importing data, manipulating it, plotting it, doing all kinds of transformations to it, filtering it, and doing additional data with it. I use Pandas almost completely in replacement of Excel most of the time, and it's very, very powerful. Jupyter is a notebook format where you can program and type words all in parallel into one big file. This allows you to explain your reasoning, your logic, your assumptions, and you can even present from a Pandas notebook, Jupyter notebook as if it were a presentation if you wanted to set it up that way. Another great application is Streamlit, which is a really great way for making web applications using Python. And then the next three, Matplotlib, Bokeh, and Plotly, are all three different packages for plotting and visualizing data. They all have methods of taking a pandas data frame and creating a really nice visual from it. Bokeh and Plotly make interactive graphics. Matplotlib is going to feel right at home for those of you that learned MATLAB in college. So when it comes to environments, there's two primary environments I use. There's many different tools out there, and a lot of them are way heavier than you need. My number one recommendation is just choose something simple like VS Code. You can open it and just start scripting right away. There's a Jupyter Notebook plugin that you can install via the extension store, and it allows you to get off right to the races. And this is my number one way to program. My second is using Colab. This is Google Colab. This is a cloud-based platform, means you don't need to install anything on your computer. You can go to Google Colab today and start scripting in Jupyter Notebooks and Python, running scripts right there. Now, some of the code that I'm going to share today won't work in Colab perfectly. You need to make a few adoptions, but it generally gives you pretty clear instructions and you can Google those solutions. So moving into examples, many of the examples here are actually going to have a little QR code on the bottom right. This is a QR code to a GitHub repository that I actually put onto my GitHub so that others could look at the code that I use to create these graphics. This is so that if you're interested, you can copy and paste and start utilizing in your own way, finding ways to manipulate and make it yourself. The first example here is standardizing energy comparisons. So this is a graphic that we find ourselves making a lot. How does the baseline compare to the design? How do we look at it in terms of end use? And I wanted a really clean, simple graphic to do that. I input some energy data as an array. I converted into a data frame. I then converted that into energy use intensity, created a standard graphic, and then I manipulated. And what took the most time is manipulating all the graphical ways in which I'm representing it, fonts, text sizes, et cetera, to get it exactly the way I want. And frankly, getting the text here to line up with the end uses took the most time by far, but it was a really, really nice aesthetic that I'm quite proud of. Each of these examples here also has a pseudocode, which is just a text representation of how the code is structured and what it's doing. So I won't explain the code each time, but it would allow you to come back to these notes, look at the GitHub and say, I think I understand what he's doing. Maybe I can start breaking it down. The next example here is for AA 2030 processing. We have a massive spreadsheet of all of our projects across the firm where we're tracking many, many metrics. That spreadsheet is not easily uploadable to AIA DDX. And so instead, I use Python to simplify our massive spreadsheet into a batch upload file, which requires a lot of filtering and correcting the data. But now that I have this Python code, I can use it every year to just filter and clean up the data and submit it online without it being this really big cleanup effort in Excel year over year that is not repeatable. Additionally, one of the most challenging things when it comes to exporting and looking at the data for AIA 2030 is that everything is area weighted. And I just wanted to provide this little function here that allows you to calculate the results of your AIA 2030 data if it's area weighted using an aggregate function in pandas. So if you import everything to pandas, you can aggregate and use this. So if you want to filter by office or market sector, this will allow you to filter by different denominators. The next example I want to share with you all today is using the OpenStudio SDK. And a word of warning is if you're new to Python, I wouldn't focus on SDKs right away. This includes ISVEs, OpenStudio, Honeybee. SDKs in some ways are their own language because each of them have a little bit of different structure. You got to learn how to read SDK documentation. But once you've become comfortable in Python and connecting it to the tools that you know and love, like OpenStudio, ISVE, Honeybee, can become extremely powerful and give you unlimited potential. So in this example, we import a file. We get all the rooms from that model. And then inside of here, I actually went into each room and removed a baseboard heater. This was created using one of the measures. I didn't want the baseboard heater in my model. I needed to replace it with something else. And doing so in the OpenStudio application would have taken a very, very long time to click all the boxes and then delete. Doing it in the SDK, once I learned the right dot notations and object-oriented properties, took me 5 seconds. But the time to figure out the SDK took me probably an hour. Additionally, another example here that I wanted to highlight is now that I remove those baseboards, I can add in components. So when I added in diffusers, I added in hot water coil diffusers, except I accidentally added them in without them being connected to a hot water loop. So to do this in the OpenStudio SDK or the OpenStudio application would have been a lot of point and clicking or click and drag into the right loop. Instead, I could use the SDK with some Python, and this is in a Jupyter Notebook format here, where I find in the same model, I say m is model dot get plant loops, iterate through them to find the one that's the hot water loop. Then in that loop, I add on the demand branch, I add the component of the coil. So I go through all the coils in the model and I add the hot water coils for each one of them under the coil heating water into the demand side of that loop. And this took me, after figuring out the last step, this took me maybe only 10 or 15 minutes to figure out the right dot notation, and it allowed me to save me many, many hours of doing it in the application or in a text editor itself. The next example here is when I do have to work with Excel, when I'm forced to work with Excel because I'm working with other people like engineers that really like Excel. In this example, we had a massive ventilation spreadsheet, one where we were calculating our full 62.1 and lead requirements and ASHRAE 170. However, we wanted to print the results and give them to our client without showing a lot of the in-between steps that you need to do for engineering calculations, but can be really confusing otherwise. So what I did is I took the original Python, and why this is so important is we had over 30 sheets when you consider the combination of different files and tabs that all combined to make what was a really intricate and detailed simulation. So series of calculations. So this script here on the right actually produced a method for me to recalibrate and control the way in which it was printed. So I could change all the print settings, I could hide sheets, I could move columns around, I could change the formatting of the cells. It's a lot of manual work in Python that you could do in OpenStudio or Excel using the OpenPyXL package. But the fact that I could script it over all 30 of those air handle units made it much, much faster to do it this way. The next one is a combination of Grasshopper and Python. Climate Studio is one of our preferred packages for looking at daylight calculations. And when you export a Revit model into Rhino for Climate Studio analysis, you get all the occupied spaces. And we often want to filter that down to the regularly occupied spaces. So what we did is Mo and our team wrote a custom Python script as a component where you not only can get the objects by name. So if you give it a layer, it will get all the objects on that layer as well as the names. You can then feed it a text string that says, if the name of this room contains bathroom or electrical or mechanical, it will remove it from the list and produce a new list that allows you to filter out those common names that you know are not regularly occupied, like corridors. This allows us to save a lot of time, especially as we re-import or export the model at various stages. We can just run it through the script, get our new regularly occupied spaces, and run our new lead daylight calculation. The last example I have for you is one that Jake and I actually programmed alongside Ji-Hoon and Ji-Wen during the Simbuild hackathon that happened just a couple months ago. And this is called Roombox. The GitHub for it is in the top left here. Roombox was developed as part of a 24-hour hackathon. And it was a really great experience where we got all various levels of sleep, but we all felt really accomplished by the amount of work that went into it and the progress and development we saw in just 24 hours. And it was really a preliminary step to something that Jake and I have been thinking about creating for many, many years that shows that this is very much doable. So what it does is typically our conventional process today is a designer comes to us, says, hey, we want to design a building with the ideal window to wall ratio, the right shading elements. How do we do this? And we as designer or as analysts will go and use Rhino and Grasshopper and Ladybug tools to run the analysis. We provide the results to the designer. We asked ourselves, could we create an easy to use tool that's a web-based platform where a designer could go and iterate themselves to find the best answer? And that's where Roombox came from. Roombox uses a combination of GitHub, mostly to host the files, Streamlit to create the web interface and make it accessible by people within our network, as well as using pollination to run much of the simulations, set up the models, et cetera, et cetera. The long-term goal is that we could create a parametric box. They can edit the parameters, click run, and get a variety of simulation options here via various building performance analyses. When we ran when we did this, we only got to the daylight step of the task in the 24 hours, but even that was still really, really great because we were able to take this interface, we could control it dynamically, change the box size, add shading elements, and then even batch upload files. If they wanted to create 3 or 25 different simulations, they could do so all in a very succinct way, click run, and it would all go to the pollination cloud. And then you could download individual results to look at the combination. Another word of warning about this, I would recommend learning Python before learning the Honeybee Ladybug SDK. This 24-hour hackathon turned into 523 lines of code. But what was the most complicated part of it was learning not only the Ladybug core tool library, but also the pollination core tool library, which is constantly in development and changing. We've been talking with Mustafa about getting some new documentation and other things to help make that process a little more streamlined. But overall, the word to the wise is these were all the different import functions of all the different packages that we had to import, from pollination to IO to Streamlit to Honeybee Radiance. It became very technical very, very quickly. So you can feel free to look at this code, but also recognize that it can be very overwhelming as you're starting out to dive this deep. And so that's all for me. I'll hand it over to Jake.
Thanks, Justin. That was a great project to collaborate on. Screen here. And we'll kick that off. All right. So my name is Jake Chevier. I'm a senior analyst at Smith Group's Impact Team. We're a multidisciplinary team that focuses on performance analytics and climate impact. I'm going to give a little bit about my background and how I got to where I'm at now, and then we'll walk through a few different case studies of things that we're doing with coding at Smith Group here. So my background's a little bit unconventional. This is not to scale, so the horizontal axis. It's not to scale. Anyway, I started off my career in the solar industry, and the tools I was using at the time were Excel, and I started making dynamic AutoCAD blocks, and I thought that was really fancy. I had a lot of fun creating those. And then eventually I started out a master's of architecture. I found sustainability to be my true passion, and that made my way into architecture so I could talk on a broader scale rather than just applying solar to a building. And that's where I really started dabbling with the Revit families, so getting more 3D with my parametric scripting. And then I also found Rhino and Grasshopper at this time. I picked it up fairly easily because if we go even further back, before I started my professional career, I did a mechanical engineering technology degree. And even as early as high school, I was using Excel and AutoCAD. But I was also learning basic C++ and programming up some pretty crude websites at that time. But it kind of paved the way for my interest into what I'm developing these days. And so circling back to the Masters of Architecture, Rhino and Grasshopper is really where I started feeling like I could create my own tools. And I really started leveraging that, and it kind of just propelled from there. So started off with Rhino Grasshopper, Ladybug tools, made my way into Design Explorer, doing large batch processing of different parametric models. And then when I was working at Arup, I started dabbling with Power BI, got really passionate about it, and you'll see some examples of that later. And then right before I left Arup, I started dabbling with Python as well, and I really just took off from there. So now I'm down at the bottom here where I move beyond just the pandas data frame manipulation and whatnot. That's great for cleaning data and structuring it. But I'm really trying to go web-based as the future of our tools here at Smith Group. And some of these icons here you'll see throughout the presentation. So we have on Python, we have the Python logo, pandas logo here, and then web-based tools. This is Streamlit, Nice, GUI, Flask, and Django is what I'm currently using for some of my stacks. I want to give a nod to that early point of my coding experience, you could say, with parametric design analysis. This is really where I kind of learned my skill set of thinking in a coding mindset, as Justin referred to it, I believe. Really where we're trying to take architecture, turn it into a design problem through a various suite of tools. Usually I use Rhino Grasshopper and a whole suite of plugins. Some of these logos you may recognize, and turning that output into data and visualization with Power BI. So what that process looks like for those unfamiliar with this is really breaking down that design problem. So for this example, we were doing a facade optimization, and we start off with glazing options. So do we have a ribbon window? Do we have like vertical punched windows? And then pairing that with shading parameters. So we could say we have no shade, we have one overhang and a few frits. We have three 4 overhangs, et cetera, et cetera. So you build up all your options, and then you start pairing those. And what this ended up being was, I don't know how to get this screen out of here. Okay, I don't know if that's like in front of everybody else. Okay, there we go.
Jake, we just see the slide. You're good.
Oh, okay, cool. Sorry. So the total iterations of all these options stack up, and it's almost 1,200 iterations. It's 292 per facade, and that really starts to become a lot. But when you can leverage the cloud and whatnot, deploy those into cloud batch recipes, visualization sort of becomes a little bit more cumbersome. So what we did here is we did the large batch processing, and what I did was took all the outputs there, and I had a CSV file. Typically, I'd throw that in Design Explorer, but I started dabbling with Power BI, visualizing with custom visualizations there. So what you see in the lower left over here is a scatter plot, and we're able to start clamping down on all those options. So what this allows us to do is take those 292 options, start filtering and saying, okay, we're not going to tell you exactly what needs to be done, unless you want us to. Some teams actually prefer that. But we're going to provide you a variety of options that perform well. So what we did is we clamped down with the SDA, we clamped down with the peak cooling, and then we're looking at a UDIA threshold as well. So what that gives us is 26 out of those 292 options. And then we're bucketing these in like a not recommended bucket, a somewhat better bucket, the best bucket, like we highly recommend these 12 options, all the way up until like an excessive bucket options, like they're letting too much glare in, the peak cooling's increasing, et cetera, et cetera. So really the design teams really liked that because we gave them options, and they felt like they still have agency over the design. For this particular facade, running all these simulations meant, and we had all these different options, meant we could deploy those across the facade in a randomized pattern to create this really textural effect for the otherwise pretty monotonous facade. So it was a collaboration between us building performance analysts and the architecture team. And that's really where we love to be in that process. The next iteration I'm going to talk about in my coding journey. So that's kind of like the Grasshopper, Rhino world of building performance. But what are we doing after that? So this is a climate action plan. I use Python, Pandas, and Power BI for this. The goal for this tool, we'll call it, is an interactive visualization of campus energy demands, the impact of ECMs on those EUIs, and the carbon projections by year. So we took a bunch of inputs here. We had EUIs for 900 plus buildings. We worked with our mechanical engineers to figure out what ECMs are manageable, what the impacts might be on those various buildings. There's a few proposed solar installations, so we rolled that into it. We're also looking at climate forecasts. So we're looking at cooling degree day changes and heating degree day changes over time, forecasting that out. And then we're also looking at grid emissions forecasts using Cambium forecasts. So this big flow chart, what you see here on the right, is kind of the equivalency of what Justin was referring to as the pseudocode. Like, what's the text version of what you're trying to accomplish with that code? And preferably, I'm a visual person. I just prefer things in some sort of tactile visual thing. So I'm using Mural here to kind of map out these calculations so that I know before I go into the code what I'm trying to accomplish. This really creates a roadmap for what the structure of the code should be. And then you're able to take that and you're able to say, okay, here's all these different pieces or measures, as Power BI calls them. And you're able to make sure that it's doing the right thing at the right time. It's much easier to QA, QC that with our engineering team and make sure the calculations are correct, rather than showing them the DAX code at the bottom here because they might not know how to write DAX code. So I use these as like leverage to do QA, QC, but also like to keep my mental sanity of, okay, this app is growing and growing. There's a lot of different calculations, et cetera. So it's a way to manage all that. So what we end up with is a dashboard similar to this. And I'm going to kind of scroll through this video rapidly. We have like campus carbon density, so highlighting different buildings on campus. We're looking at the projected weather data, the projected grid emissions, and then this is the total campus. You can filter by campus, you can filter by building use. We can look at different ECM measures. We rolled in cost per square foot as well, so we're getting a rough order of magnitude on that. We have a local solar installation here, so you could say what percentage of that load at what year do we want to install solar capacity. There's district energy system upgrades. So a lot of different ECM measures that we worked with our mechanical engineering team to make sense of what to propose on this specific project. So we're looking at carbon projections, which is what you just saw, projected energy, and then also operating costs as well. And then you can also break it down by projected EUI per building to see what those projections are going to look like. So the climate action plan team really loved this because it allowed them to create these different scenarios in real time to look at how to create how to decarb their entire portfolio. So it's a dynamic tool. It's really fun to get in there and kind of see, okay, what about this scenario? What about this scenario, et cetera, et cetera. So that was the first version of that I made. The second version we're calling Campus Carbon Planner. And this is V1, you'll see V2 in a little bit, but I was using Python to clean the data, Pandas to kind of structure that data, and then again, Power BI for the visualization. And it's not always pretty. This is a little bit behind the scenes of the sausage getting made, whatnot. But you can see I use this high-tech device called a marker on whiteboard. Basically, our goal for this is interactive visualization of campus thermal loads for CUP planning and phasing, carbon impacts, and projections. So very similar stuff to the last one, but this one we're actually looking at the 8760 profiles. And this is our initial charrette session of what we would like to see at the end of the exercise of creating this tool. So what visuals are we trying to get out of this tool? So this is me and my supervisor just in a meeting room, in a conference room, kind of discussing, okay, it'd be cool if this did this, et cetera, et cetera. So it's not always pretty, but there's a little bit behind the scenes of how this stuff kind of formulates. And again, I turn that into these flowchart diagrams so that I can quality QA/QC the calculations so that I can make sure that my measures, remember the DAX measures here, make sure that those are being calculated appropriately. And then I go through and kind of build out all the single measures, and they stack up to create the tool such as you see here. So again, I have a quick little video. So this actually has a project planner. There's many different projects on this campus that we're working with. So that allows them to jump in and create these different scenarios and say, okay, building X, Y, and Z, or it's going to come online at this year. Then the next phase is going to get built out, and the next phase after that is going to get built out. And then in real time, we're able to see these projections of peak thermal load by year. We're able to see the hourly thermal load breakdown. And then also we're able to apply different strategies. So heat recovery, wastewater recovery, geothermal. We're also able to filter out where we're recapturing wastewater from. Is it the new campus? Is it the old campus? Is it all the above? Again, we have the climate data projections. So 4.5 and 8.5 scenarios is what we included here. Et cetera, et cetera. So we're giving real-time metrics as you're moving through these different scenarios, and you're able to map out what makes sense, and then you're able to look at phasing, et cetera, et cetera. So the tool is really helpful. The client loved it. They love seeing us interact with it in real time. We are actually able to share it with them, let them interact with it in real time, because we understand that campus planning is dynamic. It's always changing. So yeah, we wanted to build a tool that responds to that. So that's that. Moving on to the next one. The Carbon app is a full Python web-based app, similar to what we used, similar to what we did with Roombox. So Python, Pandas, and Streamlit. The goal of this was to create an interactive visual of different climate zones. So I took a map here. I intersected the climate zones across the United States here with the balancing authorities. So like the grid using watt time data. You're able to search for a location here. So for instance, I always use Detroit. I grew up outside of Detroit. And what this does in real time, you're able to search for that location and pull up and get your grid mix here. So this is an annual chart of the grid mix at any given time across the year. That's all good. But then when you start comparing that, the legends don't match, right? So right now I'm at 1,300 to 1,500. And so what I built out is you're able to actually input a different location as well, and then have a comparison graph pop up automatically with the legends normalized, so that if you're looking at two different regions, and you can see Michigan goes quite red when compared to where I live now, which is Oakland, California, you can see we have a lot of solar here. So this tool is a quick interactive visualization of the different grid mixes. And our teams use this all the time. They jump in here all the time, and it's web-based and it's really easy to access. That's why I personally love the web-based tools. We don't have to fire up a whole like environment, Python, Jupyter Notebook, all that kind of stuff. Web-based, you can hand over the URL and move on from there. So that's where I'm going with the Carbon Campus Planner V2. So what we're going to see here is a combination. I'm using Figma to do the layouts. I'm using Python to build it out. I switched over from Pandas to Polars, which is supposedly a faster library. I've seen better performance. It's the same kind of concept. You're using data tables, et cetera, et cetera. And then I'm using this framework called Nice GUI, Nice GUI. I don't know how you're supposed to say it, but that's allowing me to create a much more robust interface, as you see here. So these are my Figma boards. Our goal here is to really just build off the success of the V1. So we're trying to develop a fully web-based tool that's rapidly deployable by simply uploading a new building projected CSV. So our dream is to have an upload section, and then that carries through and builds out this whole interface with the sliders and all the selections that you see here. So this is my Figma prototype. And then this is a somewhat crude version. It's still in progress, but it's actually manifesting into a pretty robust web-based interface. And this is all Python-based. So I'm using Figma to kind of lay it out. Like I said, kind of convert those early prototypes into something visual and mapping out what inputs I need, how we're going to structure that. And then I'm using Python and Nice GUI to build out that interface. And as you can see here, the charts are made with Plotly. I probably should put that logo up there as well. But this allows you to interact with this data in real time, it's projections. So we're looking forward to deploying this on a lot more campuses in real time. And this runs a lot faster than the Power BI version. So all that said, my main takeaways, and I list a few resources here that I've looked at over the years, is to don't rush it. You're not going to be an expert right away. It's going to take time. I keep feeling like I want to push things forward, and I just need to be patient with myself and realistic with my goals, that it takes time to learn this stuff. Don't overthink it. Like just kind of get started. There's so many different resources. There's so many different ways to go. I would say just don't overthink it. I do recommend Python. I think it's a pretty easy language to pick up. And I'm listing some of those resources here that I went through. So I actually did a Udacity course a couple of years ago. I've looked at a Udemy course. I've tried a Coursera course. I've tried YouTube courses. I tried Free Code Camp. I haven't tried the Odin project, but I looked at it. I heard good things about it. And then again, I leverage those large language models all the time, ChatGPT, GitHub, Copilot, and all that. So I highly recommend you finding what works for you. It's going to be different for everyone, but there's so many resources out there. So just kind of pick something and get started. And that's really what's allowed me to kind of create this trifecta of where I live now, which is performance analytics with the Rhino Grasshopper, data analytics and visualization with Power BI. And then I'm pushing all that, trying to push all that into the cloud with the web-based tool development. So that's a little bit about my background. Thank you for coming. We'll hand that off to Greg.
I am up. Let me get this going. All right. First of all, really happy to be here and be a part of this. It was really cool. We did like a quick run through last week, and it was so cool to get the sneak peek of Justin and Jake's presentations. And it's exciting to see what other people are doing, such different stuff, you know, even though we're in generally the same space. Let's see. So I'm the one talking today, but everything that I'm talking about, I wasn't the only one involved. So shout out to my awesome team. We're a fully remote energy modeling consulting company. We got into Python like 5 years ago, so not that long ago, but we dove in, you know, right away, and it's drastically changed how we do our work and even our team makeup. So in addition to myself, we've got 3 building performance analyst engineers that are mostly doing energy modeling work, and everybody's using Python in some extent in their work. And then we have Sabrina, who is a full-time software engineer that joined us last year. So we're fully committed. So why coding in BEM? You're here, so you probably know already, but I like to think about it in kind of three main areas where, automating repetitive tasks to get it done faster, more consistently, higher quality. Analyzing, models have so much data in them, and then you're generating so much data through simulations. So manually kind of reviewing that, like there's some tools integrated into software tools that are great, but it still takes a lot of, user work. So Python, et cetera, can really help with that. And then sharing that data, especially in more dynamic and interactive ways than the past. Which, speaking of the past, so historically, I and our team, we've been using ISVE for many years for our heavy lifting BEM tool. Historically, automation and reporting has been Excel, and copy paste stuff into a Word document and send a PDF to a client. So the industry has evolved with technology, with data analysis, and we saw that happening and have been working feverishly to get on board with all of these tools, with Python, pandas in particular. Like if you take two things away today, it's Python and pandas, in my opinion. But we're working hard to get rid of Excel in our work, because these other tools it's better, faster, cooler, better user experience. So this is kind of where we've evolved to acknowledge the analogy there. And then all this is going to be a few snapshots from throughout our journey with examples that start smaller, more accessible, hopefully inspire some people to like, to jump in because it's not that hard. And then I'll show you kind of what we have and where we're going from there. Number one, I would say, is stop procrastinating, waiting for the perfect course or the perfect project. Just dive in. I think I'm, 3 out of 3 for saying that one today. But I will share some courses too. This is the third Intro to Python course I think, you're seeing today. So you don't have to take this one. This is the one that our team has taken through Coursera, University of Toronto, learned to program the fundamentals. But yeah, tons of sites. YouTube has lots of free stuff that's awesome. So just dig in, take something. And then I would say take the intro course, and then I would definitely recommend this specific course from Clayton Miller at the National University of Singapore, because it's data science for our industry, for construction, architecture, engineering. You probably don't need like a Python course to get through it, but I would highly recommend taking one because it'll just help you progress your learning curve, and you'll be working on things like exercises that are within building energy data and things like that. So yeah, I would definitely recommend that one. And then if you're working on a team, if you're just scripting by yourself, this isn't so important. But for us, all of our team has taken this course to learn version control using Git. So if multiple people are contributing to a shared repository, you need something like this. And I would recommend that one. So kind of going back to the timeline, one of the first things that I got into after taking these courses was to extract hourly results data out of ISVE to a CSV file in a standard format. The way I created this script was really adapting an example script that is in VE's Python API. So this is the example script. I saved a copy of it, started tweaking, got rid of some stuff I didn't want, focused on energy, and then started generating probably an earlier version of this CSV file that just expedited analysis externally. So this is still available in some of the later tools I'm going to show you as a CSV file, but we're also using that in a lot of the newer analytical tools that are Python based, but you could definitely, use that in an Excel tool yourself as well. So that one, very approachable, fairly easy to get started. As Justin mentioned, like it's good to have the fundamentals, like be familiar with Python on its own before trying to also be learning, the VE API or some other SDK. But once you're there, very accessible. So the first thing, like I mentioned, we got the data out and then wanted to build a dashboard. So the energy results dashboard, version 1 was kind of the next thing we built. I'm not going to show that here because I'm going to show you a later version in a second. But that was the next step along the timeline generally. That one was, we used Plotly Plots Dash, which is a Plotly dashboarding product. And then Heroku used to have a free, I don't think they have a free tier anymore, but it's like kind of easy to get started way to launch and host a web app. Didn't take too much to get that going and have like a web-based dashboard. The next thing that we did was, we do a lot of lead energy modeling. So if anybody has had to fill out the lead MEPC spreadsheets, you know how tedious and cumbersome that is. So we're like, we really need a way to get HVAC system data out. So that was one of the next things we focused on. This is just a snapshot of that. Not too sexy. It spits out an Excel spreadsheet, workbook that has a summary table, system by system on the first sheet, and then in VE they call it layers, but spaces or zones information. So if you have VAV reheat coils or something, you can get the zone by zone data as well. So just allows us to fill out that spreadsheet faster, and we have more plans of doing cooler stuff with this data. But yeah, that was one of the next things along our journey. This next one, I'll show you an example. So this is one my colleague EU spearheaded. And basically, if you have a VE model with a chilled water loop and a hot water loop, and you're interested in understanding the potential for heat recovery, great decarbonization strategy. Whether you have boilers, heat pumps, doesn't matter. But yeah, in this case, you just need one of those, each of those loops, and then we're pulling that data, analyzing it. All of these are Plotly like indicators or plots. They're dynamic. It breaks things down month by month, allows some user interaction. And then this version, it's just like a simple HTML file that will open within VE's content manager, which is kind of like a little web browser where you can open files within the software. Eventually this one will be web hosted, but this one, yeah, right now it's just kind of within the tool for our projects. And then, so the BEM toolbox is essentially like we got into Python, hit the ground running. We're really excited about what we were able to get out and start building. And so we had these cool tools that were starting to come together, and we wanted to do two things. We wanted to share the tools with other people because we're like, okay, this is a game changer for us. I'm sure lots of other energy modelers using VE or other tools or really would benefit from these. So we wanted to share them with other modelers, but then also we wanted to, take advantage of the like modern way, modern form of data reporting, which isn't the Excel and PDF. It's really dynamic and shareable. So we wanted a web tool where we could send a client a link and they could click on it and open up that report and start playing around with things. So we built this platform to do that. It's called the BEM Toolbox. We got somebody to help kind of with the architecture and setup of the site itself. Now Sabrina's been running with kind of improving that and maintaining it, so we can do that internally at this point. Free to create an account, sign up. You have access to these tools. This is kind of the workflow once you get in. This is showing the instructions, showing a link. You can click on that. It'll take you to a free Python script on IS's content store. So you can download that, install it within VE. I'll show you that in a second. But here's the HVAC summary spreadsheet report I showed you before, and how you can have access to that one as well. And then here's an example of one of the dashboard like analytical tools that is available through there. So this is the second version of the one I mentioned earlier. And so again, you know, everybody here has been a fan of Plotly. We are as well, because it's a Python library that creates plots that are based in other things, JavaScript and things like that, that are just more dynamic and interactive. So you just get that out of the box, and you can make them look really nice. The dashboards too, you know, at the bottom, you could see you could create a public link, click a button, it copies the URL to your clipboard, drop that in an email, send it to your client or, you know, design team partner, and then they can open a version of this that doesn't require an account to be created. So they won't have all the, you know, be able to go back and see other tools. They just get the one dashboard view. And yeah, people have been a fan of that so far, and it's been, you know, more fun to do this and easier to generate than creating the old version, and then, you know, more value on the other side too. So it's a win-win. So the IS content source scripts that I mentioned, once you download them, they will install these navigators within the VE Python scripts navigator. So this allows you to enter your BEM toolbox credentials. It was popping up, you know, having it'll get gross area, square footage, or sports metric as well. But gross area from your project give you the ability to tweak that if you want to exclude parking garage area, something like that. And then it will send the data to the BEM toolbox, open the dashboard in a browser directly, and you can just get in and start playing around with that. That dashboard we call it the multiple energy results dashboard. So basically focused on, like, if you're not in a just baseline and proposed compliance scenario and you want to compare 3 or more sets of results, might not do 1,000 very well, but, you know, doing I don't know, 5, 10, 20, it's pretty good. And then you can change the reference model that you're comparing against. You can pick different end use category to drill down and get different graphics there. So adding a little bit more customization, user interaction into this dashboard. Not showing you everything on there today just due to time, but I did want to mention we have a couple of videos on our YouTube channel. Bhakti on the top right image recorded this presentation that she gave at Simbuild a few months ago, actually, that showcases the greenhouse gas emissions summary report that she put together, kind of comparing EPA flat emissions rates versus Cambium. And, you know, it's a, you know, first version of this that we're working on, kind of advancing, but, you know, hourly carbon emissions are important to start understanding and looking at, but it's a lot of data, hard to calculate. So we wanted to make that easier and more accessible. There's also a LEED pilot credit, alternative energy metrics pilot credit, that will create the workbook for you that you can submit to LEED to hopefully get a few more points under V4 prior to the 2024 update. And then on the right, the bottom image is my other colleague, Yu, who led the charge developing a custom parametric tool that we've been using within VE. It's focused on envelope parametric simulation. We've been using that on our projects for a year or so. This one's harder to share because there's so much happening within VE. So this one isn't available, but I believe IS just launched their own parametric tool. So you probably won't need this one yourself. But yeah, we have the YouTube channel. We've got plans for more stuff coming. That's where we want to use to share what's going on. So if you're interested, please check that out, and you can follow us. And yeah, that's it for me today. Thanks so much.
Thanks so much, Greg. Well, now we can get started with the Q&A portion of our webinar. I'll start off with a question for everybody. I guess there's also a question in the chat about if the webinar will be recorded. It is recorded and it'll be on the IBPSA-USA YouTube channel after the webinar. So question for all of you guys, just to start off, is what does coding look like at your firm? Are you the only one who codes? Does everybody code? Do people who not know how to code know how to use your tools? What does that look like?
I'll go first. So my firm is very large. We're over 1,300 people. So definitely not everyone codes. I would say on our team, there's a variety of skill levels. Some in some regards motivated by those that do code and seeing some of the things that we do. Overall, the workflow tends to be that those that are more experienced with coding might hop on and say, hey, I can write a few lines of code that makes this problem go away or solves this problem much faster than a conventional method, maybe using Excel or Grasshopper and using a whole bunch of Grasshopper components when you can write just a couple lines of Python code to do it much faster. So we generally write a variety of scripts using Python, Grasshopper, and then share those with other people in our group and other people outside that are more experienced with it as well.
Yeah, for that, not everybody at our firm programs. Our team's a little bit more niche, so we are in the computation world. We're deep in the IES world, so some people on my team are starting to adapt coding more to kind of leverage the existing tool set that they have. But I've kind of taken it by the helm, really pushing stuff forward. So sometimes I can collaborate depending on what it is, but mostly that's why I'm trying to go web-based, is that I can hand off these tools to let them run it on their own.
And then I think I mentioned this a little bit, but everybody in our small firm does some coding. So before we had a full-time, developer on the team, I'd say everybody did, I don't know, it was like 4 to 8 hours a week or something that we were kind of actively encouraging, developing tools, getting things on the BEM toolbox and whatnot. Since Sabrina joined, she's taken over, a lot of the heavy lifting. But our team is now, the focus has shifted, I guess, a little bit away from making the tools available and putting the skills to use in like analyzing model data, coming up with different, like the heat recovery analysis script, different versions of things like that they can put together for a project. And then use it on the next project. Yeah.
Cool, thank you. I'll hop over to our Q&A now. Jake, there are a bunch of questions on the campus action planning tool that you created. Can you elaborate a little bit more on the data set that was used?
Yeah, depending on which one we're referring to, we've done historical data, but also future forecasted data. So for the future forecasted, we'll do a surrogate model. We'll find a similar building prototype. We'll run it in that specific climate for that campus, and we'll project that out over the master or the campus plan that they're giving us. For the historical stuff, that data comes in all shapes and sizes. I wrote in one of the responses that sometimes it's BMS output, it's 5-minute intervals, it's divided across 500 different spreadsheets. That's where Python truly shines, because you can automate it. You can have it open up those spreadsheets. You can normalize it back to an hour profile, develop those 8760 profiles. So yeah, the historical stuff comes in all shapes and sizes. Sometimes from a a carbon management software, we'll get like the EUIs or the total carbon for that year. But BMS data comes all the time as well. So all over the place.
And kind of a funny mini story is when I saw Jake's presentation, I realized one of the projects he shared, we also worked on, and we were pulling BMS data to do like quarterly and annual energy reports against design-based targets. So we were like very disconnected in terms of the different people on the campus we're working on, but it was cool to see what you were doing with, other types of similar data.
Justin, I saw you answered a few questions in the chat. Do you want to say any of what you shared out loud just for the whole group?
Sure. I also wanted to, in parallel, address a comment that was like, hey, how do you guys learn on the job? I think that that's a really good question. And frankly, a lot of what you see was developed in stages. As Greg talked about, like each one's a stage. So a lot of times, the first time I do it on a project, it doesn't save me any time. So, yes, I took those courses, and I think we all took some courses in our own personal time, whether it was doing my PhD or whatever. Maybe Greg's team, they said, hey, part of your in-house, you're learning, but each piece is kind of built sequentially. And that's one of the nice things about code is that it's very repeatable, while doing things in Excel might be not as repeatable, though you can make it. So the point is that, like the graphic that I showed where I'm comparing the baseline versus the proposed, that was iterated over probably 5 projects to get it to that level. So when you're building it kind of over time, you're kind of investing in the development of something that allows you to learn and get better and better at it one step at a time.
Yeah, and
Great,
for
thanks.
us, I didn't like, I'm not paying people to learn to code. Like the way we're kind of like, we're innovating, but we've got this like entrepreneurial viewpoint on it. At least I do. So I encouraged and supported people to do these courses, but they essentially did it on their own time. And then after, if you're building things that the company can benefit from, and we kind of do a little like pitch me on this idea that you have. And it's not just, hey, I want to build this thing because it looks cool. It's like, what problem are you trying to solve, right? And then what's a rough like ROI? How many times a year are we going to be able to use this? And so if that you can kind of connect those dots and put that together, then cool. Now I'm paying you to do that. It's like part of our work because it comes back around and we'll eventually recoup that investment.
Yeah.
Thanks so much, everybody. We are a little short on time, so I'm going to turn it back over to Jackie and she can close us out.
Hello, yes, sorry about that. Thank you to everybody. Thank you to Justin, Greg,
Jackie, you're echoing.
I am echoing. I'm sorry. Is that better?
Yes.
Okay, there we go. Thank you to Justin, Jake, Greg, and Kate, and thank you to everyone for joining us today. Please check out the IBPSA-USA website at IBPSA.US for upcoming events and other webinars and chapter events. For you watching this back on YouTube, please like the video and subscribe to our YouTube channel. Again, thank you all for joining and have a wonderful rest of your day.